All right, so today we're in section 2.1, translations. It's the first type of transformation that we're going to learn out of our four types of translations. But in order to understand translations, you have to know what this is. What is it, guys? It is the coordinate plane. And what axis is the horizontal axis? X. And what axis is the vertical axis? Y. Okay? All right, so what is this? What do I call this? I call this, I heard it, an ordered pair. I call it an ordered pair. Ordered pairs tell me where to plot the point on the graph. So would I go right 5, or I'm sorry, let me back up. Is the 5 my X value or my Y value? X. X always comes first. -2 is my Y value. So now that I know 5 is my X, would I go right 5 or left 5? I go right 5, but that's not where I plot my point. Now do I go up 2 or down 2? I go down 2 and plot my point. So does everybody agree that this matches with the ordered pair? This point matches the ordered pair. All right, so you have to know this. You have to understand this in order to be successful in chapter 2. How points are plotted on the ordered pair, with ordered pairs on the coordinate plane. All right, and you'll see more of why this is important in example 2 today. All right, any questions? So in example 1, we need to write 2 terms down first before we get to example 1. A transformation and a translation. I'm going to give you a minute to write these down, then we're going to talk about what they mean. A transformation and a translation. All right, so what helps you know the difference between, let's say, in a matching section, if it was translation, reflection, rotation, dilation, all the different types of transformations, how are you going to know which one is which? Here's how. A transformation, okay, that's my overall. What is a transformation? It changes a figure into another figure, and the new figure is called an image. That's really important. So the new figure that is made is called the image. All right? A translation, here's what makes a translation different from the others. It slides, but it does not turn. And every point moves the same distance and in the same direction. So one point's not going to go right and the other point go left. Okay? They're all moving in the same distance in the same direction. Okay, so yes, now example 1. Is it a translation? Well, here's our criteria. It cannot rotate. It can only shift left and right, up and down. So if the figure rotates at all, it is not a translation. See, I almost did it. It's not a translation. If it changes in size at all, meaning it shrinks either up and down or left and right, it is not a translation either. It has to be, again, all points have to move the same distance in the same direction. So, with that being said, just kind of sketch these first 2 shapes, and you decide, do these 2 shapes meet the criteria of a translation, yes or no? What you think? Who says yes, it's a translation? You are correct. You are correct because it shifts right and down. Nothing rotates, nothing turns. It is the same size from what we can see. Now, I'll tell you this too, on a quiz and a test, I'm going to make it obvious that it's one's bigger and one's smaller. You're not going to have to wonder, oh, is it just a hair smaller or bigger? I'm not going to do that. That kind of defeats the purpose. It will be obvious. Okay? So yes, this is a translation. Okay? And that's all you have to say is yes or no. So this is 3 questions on your homework tonight. Just yes or no. All right? Go ahead and sketch these figures, and while you're sketching them, I want you to answer the question, is it a translation? Lily, yes or no?
No, because it turned.
Very good. No, because it turned. So you would say no. But to know why. So in the last class I said, all right, what do you think? And someone said, no. And I said, why? He said, I don't know, I guessed. Do you think he's going to get it right every time? No, you have to know why. If you know why, then yeah, no is the obvious answer. All right, last one for example 1. Is it a translation? Go ahead and sketch them and then say yes or no, and to know why would kind of ensure that you understand, and you could get more of these correct if I gave you a bunch more. Who wants to answer this one, yes or no? Elizabeth?
No, because it changed in size.
Very good. No, because it changed in size. Easy enough. Don't you wish you could just take a test on example 1? It'd be pretty easy, huh? Okay, but that's translations, okay? Now we're going to make our own translations in the coordinate plane. This is a very important example, okay? If I could give you a snapshot on what you would see on a standardized test, SAT, ACT, translations are going to be transformations, especially. Even more specifically, what you're learning in example 2 is very important, okay? And it looks really confusing at first until you understand what's actually happening. Then it's not so bad, all right? So you do need a sheet of graph paper. We're going to do one graph, all right? So go ahead and get out a sheet of graph paper, and we're going to do one graph together. If you don't have graph paper, you can do it on your regular paper. But I prefer graph paper, and especially on your homework, you'll need to use graph paper on the ones where we're graphing. So we all set up our grids or graphs. All right, so now we are going to plot an image on the coordinate plane. Okay, what is the ordered pair for point A that I've plotted? Look at it, don't say it yet. What is the ordered pair that matches point A? Ethan? No, not quite. Maya?
3.
No. What number comes first, Sherelle?
-4.
-4, 3. Remember, our x comes first, so I went left 4, up 3 to get to my A, so that's how I came up with -4, 3. All right, here's point B. I want you to write the ordered pair that matches point B. On your homework, you're going to be asked to do this in reverse, where they give you the ordered pair and you plot it. Okay. So what's the ordered pair that matches point B? Anybody have it? Joshua? He said 2, 5. That is correct. 2, 5. All right, and then point C. Point C. What's the ordered pair that matches point C, Elizabeth? 2, -2. I can tell I'm hitting some of your strong suits. You're pretty good at the coordinate plane, ordered pairs. Okay, so that's good. This is kind of a change of scenery from chapter 1. All right. If I connected these dots together, what shape would it form? A triangle. Go ahead and connect your points together. As straight as possible. Obviously, mine's not perfectly straight. Okay. All right. And here's what my directions say. All right. I'm going to shift back. Everybody have this? I'm going to shift back real quick. Here's my directions. Translate the triangle 3 units right and 3 units down. So here's what I'm going to do. For each point in the triangle, I'm going to, I don't want to put the whole thing up there. I'm going to shift each point over. Okay, so on point A, it was at -4, 3. So now I'm going to take point A and I'm going to shift it to the right 3 units. So now it goes from -4 over to -1 and down 3. And my new point becomes, what is the ordered pair for my new point? -1, 0. Okay, and that's my new point A. Now, again, to make it a true translation, each point has to move in the same direction and the same distance. So if I move point A, right 3, down 3, guess what I'm going to do to point B? Write 3 down 3. Do it. Move point B now and move point C. Okay, so point B, did you put it at 5, 2?
Yes.
And then point C, did you put it at 5, negative 5?
No.
Okay. 5, negative 5? Okay, and what your book does, I did not do this in my earlier classes, but I like this idea. Because you're working in pencil, what the book does is they make it a dotted line for the image that was translated instead of a solid line, and that just helps you see which one was the original figure and which one is the translated figure. Okay, I think that's a good idea. It's an image, guys. The green figure is an image of the purple figure because, and it's a translation because I moved the same distance and in the same direction all 3 points. All right, that looks kind of fancy, but not too difficult. All right, so that is one method that you can show a translation, all right, is by graphing it on the coordinate plane. But what if you had, and you're not going to have on your homework, but what if you had like 10 of these to do? Would you prefer to do 10 graphs?
Yes.
And set them up? You would? Okay, some of you would prefer graphing, and that's fine. But what if you don't prefer graphing? It's good that you have another option. You have another method. If your instructions say, your instructions are still the same, to translate the figure 3 units to the right and 3 units down, you can actually do the translation in the ordered pair. Okay? If I'm moving 3 units to the right on X, is that positive 3 or negative 3? If I'm moving right, it's positive. So all I need to do is add 3 to my X value for each point. Okay? If I'm moving 3 units to the right, I just add 3 to my X value. That's all I do. And if I'm moving 3 units down on the Y value, would that be minus 3 or plus 3? Minus 3. All right. So what's negative 4 plus 3? Negative 1. And what's 3 minus 3? 0. And since I have the graph, now we're kind of pretending that the graph's not there, but since I have the graph here, let's go ahead and compare. Is point A at negative 1, 0? Yeah, it is. So this method works the exact same way as graphing it. If I didn't want to graph or if I was asked not to graph, I could solve it this way. All right, you go ahead and do point B. Pretending that it's not already graphed and you don't already know the coordinates, go ahead and plug it into the ordered pair. Again, each point has to be shifted the same direction. So if I added 3 and subtracted 3 on the first point, I have to do the exact same thing to all my other points, B and C. All right, so again, if I add 3 to X on A, I've got to add 3 to my X value on B and subtract 3 from my Y value on point B also. So what's 2 plus 3? 5. And what's 5 minus 3? 2. Oh, not negative 2. 2. And does that match with my new point B, my image? 5, 2? Yep. All right, and then point C, again, 2, negative 2, and I add 3 and subtract 3. I have to do the same thing to all my points in order for it to be a translation. So my new point C is at 5, negative 5, and yeah, that matches up with my graph. So it's one or the other, guys. Do you have to do both? No. Okay, I just said that. It's one or the other, okay? You either graph it or you use the ordered pairs, but those are your 2 methods for translating a figure. Those are your 2 methods. How many of you would prefer to graph it and you like to see it? You like to see it on the graph? How many of you say, I like the ordered pair? Okay, so it's really just a matter of preference unless your book asks you to do one over the other one. All right, so that's it for part 1. Tomorrow we're going to explore translations, like drawing them a little bit more, and example 3.
Can I have Ethan?